What's going on, guys? Sam here for Boundless Entertainment, and in today's video I'm going to be going over our brand new plugin LightForge, which is going to allow you to quickly and easily optimize and maximize the quality of your scene to be able to get the most cinematic high-end results possible. Right now I'm in the project file from the Unreal Engine for Filmmakers course. I highly recommend you check out the Unreal Engine for Filmmakers course. I show you how to make this scene completely from scratch. So what we have right here is a sequence. We have animated characters running. We have a ship flying overhead and all kinds of crazy stuff going on. So where LightForge really excels is in providing speed, flexibility, and potency into your workflow so that you can quickly and easily optimize your scene for the best possible quality. So to demonstrate, I'm going to first enable the plugin. So I'm going to go up into Edit, and then I'm going to go down here to Plugins, and I'm just going to type in LightForge, and it's going to come up here. We're going to click on this little toggle switch, and we're going to have to restart our engine to have the changes take effect. Alright, so I'm back in my project here, and if we go here to Window, and then we go down and grab LightForge, it'll pop up in this window. It might come out as its own separate window for you, which is really nice. You can move it around however you like, but I like to dock it right over here next to the world outliner. So I've just reset my scene to the default settings so I can show you guys how LightForge works. So the first thing that we have here is we have our enable path tracing switch. And normally to enable path tracing, we have to go in here to Edit, and then into Project Settings, Engine Settings, and we have to go down to Rendering, and then we're going to have to scroll down and find a couple of settings in here. The first one being Support Hardware Ray Tracing. We're going to have to turn that on. So turning on Support Hardware Ray Tracing is going to require an engine restart. Then we're going to have to, once it restarts, go back in and enable path tracing. But before we do any of that, we also have to make sure that we have our default RHI set to DirectX 12. And once we've done all that, then we will be able to use path tracing. However, with LightForge, we're actually able to just go up here and click this button. It's going to give us a warning, so that's just to make sure that you double check your system requirements to make sure they meet these. Otherwise, you're going to want to click cancel. But in our case, our system meets these requirements, so we're going to click OK. It's then going to tell us that we need to restart our engine, so we're going to click on yes, and it's going to restart the engine for us. As soon as the engine starts back up, you can see we actually have a significant improvement in the realism of our lighting, and that's because we have hardware ray tracing enabled. And you can also see that now we can go up here and go into path tracing mode. However, it does introduce some problems when we turn on hardware ray tracing, like with these meshes, for example. As you can see, the meshes look very low quality. If we go back into lit mode, you'll see here they look very nice and detailed, and if we go into path tracing, they look terrible. And this is because of the fallback mesh, which we're going to get into in a little bit, and how LightForge fixes that for us. But that's something for a little bit later in this video. The next thing that we have here is we have our path tracer and lumen settings. In order to modify these settings, normally we have to have a post-process volume or a cine camera actor, and we have to go into our post-process volume settings. And then we're going to have to go down here to global illumination, and we have our lumen settings in here, and also we have some reflection settings down in here. For our path tracing settings, we're going to have to go down here to path tracing, and we have our path tracing options right here. So we can modify our max bounces, samples per pixel, max path exposure, etc. And you know, if you want to learn more about that, I highly recommend you check out the Unreal Engine for Filmmakers course. So it's kind of inconvenient always having to go into your post-process volume or your cine camera actor. LightForge is nice because you can actually modify those settings right from here. And the way that we do that is by going here to select a post-process volume. We're going to grab our post-process volume that we have in our scene, which is right here. We can easily modify any of the settings right here from this central console. This is going to allow us to actually make adjustments right here from this console. So if we go into path tracing, I can show you guys. If we set our max bounces down to 0, you're going to see that it's going to set our scene completely dark, so that's how you know it's working. We can set our samples per pixel down to 100, and let's set this up to 8. We also have a nice reset feature right here, so you can reset any of these to their default values. You can also modify the reference depth of field, reference atmosphere, and the denoiser. You can modify all of these path tracing settings directly from the LightForge console. Now, what's really nice is instead of doing all that, you can just click on optimize, and that's going to input the settings that we have found to be best in terms of performance and quality when it comes to working in your Unreal Engine scene. This is going to give you a really good starting point. You can always easily modify and tweak these settings from here if you choose, but this is going to be a great place to start. So next we have our lumen settings, and if we go down here and switch back into lit mode, since we have our post-process volume selected, it automatically populates our lumen settings area with the current settings for our post-process volume. So if we go in here, we can change our global illumination method to screen space, for example, and you're going to see we have all kinds of nasty stuff going on, and we can change it back to lumen. We can also modify our lumen scene lighting quality. We have our lumen scene detail. So what I'm going to do, instead of going in and modifying these all myself, is I'm just going to click on optimize. It's going to automatically set our lumen settings in editor here so that they're going to be optimal for the best possible quality for our scene. This is only a small part of the equation when it comes to our lumen settings, because we're going to use LightForge's render presets to actually enhance our lumen rendering quality even further. Clicking optimize is going to get your scene to a really good place in terms of quality, and you're going to be able to modify these settings as you need without having to go into your post-process volume and modifying from here. The other thing is, when we click on optimize, LightForge is also actually doing a couple of things under the hood. If I go into my post-process volume and I search for infinite extent, you're going to see that this is checked, and by default this is actually unchecked. So what LightForge is doing is it's enabling this feature so that you don't have to remember to enable it, because if you don't enable infinite extent, this post-process volume is only going to apply within this little box right here. Whereas if you click infinite extent, it's actually going to apply to the entire scene. And so LightForge kind of takes care of a few of those small details that are easy to forget and that might cause you some headache and some problems when you're working on your project. It's also doing a couple of other things under the hood. So if you go up to our edit and then project settings, if we type in separate translucency, it's actually turning this off. And this is optimal because separate translucency actually causes problems when rendering the depth of field of media plates. Any object in your scene that's translucent is actually going to render without certain post-process settings such as depth of field. And this is going to cause you a ton of problems when you're trying to use media plates that have translucency, like fog cards or things like that. It can also cause some trouble with VDBs. So if you uncheck this, it's actually going to really benefit you, especially if you're using things like media plates. And LightForge automatically does that for you. Obviously, you can go back in and modify that setting yourself if you choose. But these are just some of the handy features that LightForge is performing under the hood so that you don't really have to worry about these things anymore. So that is the basics of scene optimization, but we also have one more section right here, and that's going to be our nanite mesh optimization. So nanite is a big deal. If I go into my nanite visualization, basically our entire scene has all of these little triangles that are being rendered and modified in terms of their scale in real time as we move further and closer to the meshes in our scene. And that is essentially a replacement for LODs, which stands for levels of detail, and it's performing the function of an LOD in real time, but seamlessly, so that we can't actually see it happening. So if I zoom in and zoom out, you're not going to see the change in the mesh's level of detail as we move closer or farther away. The problem is that nanite doesn't really play very nicely with hardware ray tracing, ray traced shadows, and path tracing. Like that issue we talked about before, if we go into path tracing mode here, you're going to see that we have these really low quality meshes. And that's because of our fallback relative error being set to 1. And you can also see that if we go into lit mode, we have this weird shadowing that's very unpleasant, and it's happening all over these meshes that have nanite enabled. It's less obvious on these smaller meshes, but you can still see we have lots of artifacting going on here, and that's very undesirable. It doesn't look good at all. And that's because we have ray traced shadows enabled and nanite enabled on these meshes at the same time. And we do want to use ray traced shadows because we get these really nice looking soft shadows here that are going to to be realistic to what they would be in the real world, where you can see that here this shadow is a little harsher, and over here we can see that the shadow is much softer. And that's because in the real world, as the shadow gets further away from the original source object, the softer it's going to be. So we want to use these nice ray trace shadows in our scene. It's going to make a big difference for us. So how do we get these components to play nicely with one another? Well, there are a couple of different options, and LightForge is going to streamline that process big time. So the first option that we have here is to set the fallback relative error for all of our nanite meshes in the scene to 0. We can do this manually by going in here to our details panel by clicking on a mesh, and then if we go into our static mesh right here, then we can set our fallback target from auto to relative error, and then we can set this down to 0, and then we can click on apply changes. And you're going to see that it's going to take some time. Typically it's going to take you between 15 and 20 seconds for each mesh. Okay, so if I save that, give it a second there. If we go in here, now you can see that that shadowing issue is completely gone. And also if we go into path tracing mode, we have our full quality mesh right there. You can see that there's no difference really between lit mode and path tracing mode on this particular mesh. So that fixes a large problem for both using ray trace shadows with nanite in lit mode and also using nanite meshes with path tracing. But if we want to do that, we have to go into every single mesh in our scene and modify each one. And that's going to take forever because I have probably 100 meshes in this scene. What we can do is click on this set button for the mesh fallback relative error, and it's going to come up with a little dialog box here that says optimize scene for path tracing / ray trace shadows. 441 nanite meshes will be optimized. So if we click on yes, it's actually going to go in and modify that setting for each mesh in our scene, and it's going to do so with much more efficiency than is possible by doing it manually or even through the bulk edit mode in the engine, because this is actually kind of working under the hood and going in and doing this using the baseline functions of Unreal Engine. And so that's going to actually increase the speed at which this process is completed significantly. I'm not going to do this yet. I'm going to save that for last because this is the most time-consuming fix for this problem, but it can also be the best one. So I'm going to click on no. So if you want to reset your mesh fallback relative error, you can just click on reset and you'll be able to reset any meshes that you've already set the fallback relative error for. Now that we're back to having this problem again, we can fix this issue by using a simple console command. And that is going to be this nanite mode mesh optimization option. So if we just click on set, LightForge is going to apply this console command for us. And that console command is going to be r.raytracing.nanite.mode, and it's going to set it to 1. And so that is actually going to reference the streamed out mesh instead of the fallback mesh for all of these nanite meshes in our scene, and it's going to fix that problem with the ray trace shadows. So we're getting rid of all of that weird artifacting on our meshes. There's no more weird shadows. And also if we go into path tracing mode, you're going to see that it's going to give us our full quality mesh in path tracing as well. So if we go to lit mode, you can see there's really no difference between path tracing and lit mode. So this is going to be the first method that I recommend trying. However, what can happen sometimes with using this console command is that it actually will sometimes introduce some strange artifacting into our shadow areas. As you can see right here, if we go into path tracing mode, that's also going to be apparent there as well. Sometimes you will also get some strange artifacting with the edges and corners of some of the meshes in your scene when you're in path tracing mode. That is why I say that sometimes mesh fallback relative error can actually be the better solution, even though it's going to be a little bit more costly in terms of time, because it's going to provide a little bit better results with some of your shadowing, and it's not going to have any of those weird little artifacts that I was just talking about. I definitely recommend using the nanite mode console command setting first and see if that fixes your issue without any noticeable problems, because you can see that for the purposes of this scene, this is perfectly fine. We're not really seeing any of those issues. We have some really good looking geometry here. And what's great about LightForge is that when it applies a console command like this, it actually applies it to the engine so that when you restart the engine, so if you close out of the engine and then open the project again, again at a later time, those console commands are actually going to stick, and you're not going to have to go in and retype the console command every time you reopen your project. So that's really nice, and you can also always reset it at any time to the default value. The last thing that we have here in our nanite mesh optimization section is our two-sided geometry mesh optimization setting. So you can see, we have this kind of weird shadowing going on, these little black dots all over the geometry. You can see them out in the distance as well. And neither the mesh fallback relative error setting nor the nanite mode console command fix this problem. And so the only real way to fix this when you're using ray trace shadows with nanite meshes that I have found to be effective is to use this two-sided geometry setting. And what that's going to do is actually set this console command r.raytracing.shadows.enable two-sided geometry to 0. It's currently set to 1, that's the engine default, but if we set it to 0, we're going to see what happens. So I'll click this set button. And you're going to see that now that artifacting and those weird shadows have cleared up on all of these meshes. This is a great setting for clearing up some of those issues. It can be very annoying. When you apply it using LightForge, it applies it to the project permanently. So the setting is going to persist, and you're not going to have to go in and retype that console command every time you want to use it. You can also reset it at any time to the default value if you choose, but you can see that combining these methods together, we're actually able to completely get rid of those artifacting issues, and we're also able to get our full quality meshes in path tracing mode without much trouble. So if we go into lit mode once again, I'm also going to show you guys how fast this mesh fallback relative error setting can be. So I'm just going to go in here and click on set, and it's going to optimize 452 nanite meshes. We're going to click on yes. And you can see that for a scene of this size and scale, this was really a pretty quick process and pretty painless. And we're able to overcome those issues in a variety of ways. So you have the option to choose for yourself and for your particular project what is best for you. Okay, so our scene has finished optimizing those nanite meshes, and now we can see that we have no issues with the shadowing whatsoever. And once again, if we go into path tracing, we're all good to go, and we don't have any of those problems. We have our nice quality settings all set up for lumen and path tracing, but let's render this. Okay, so what we can do is go into our sequence here, click on render, and it's going to add our sequence to the movie render queue. And what's great about LightForge is that it comes with several great ready-made render presets that are going to give you the maximum quality possible in your Unreal Engine scene. So if I click on this drop-down arrow, it's going to give us several options to choose from for rendering our scene. So we have our deferred no render passes, we have our deferred rendering with the world depth and the motion vectors passes, we also have our path traced render with no render passes, as well as a path traced render with world depth and motion vectors. So all we have to do is click on the setting that we want, and we can set our output path right here, set it wherever we choose, and we can set our output resolution, and we can just click on accept and then click on render, and that's going to give us a very nice high quality render out of Unreal Engine. If we go back in here, however, we can also go in and modify the anti-aliasing to get a higher sample count or a lower sample count. We can also go in and add stencil clip layers. We can use post-process materials here with the world depth and motion vectors or any other render passes you want to add. And you can go ahead and modify any of these settings. We can also use an open color IO configuration. We can also add console variables right here. I already have 15 different console variables added, which are going to optimize your scene like you would not believe. And we also have our path trace rendering. If we go in here, you can go in and modify any of these variables as well, or you can modify any of the other render settings that we've applied here. Basically, that's going to, at the very least, give you a great starting point for getting the highest quality cinematic renders out of Unreal Engine. And in most cases, it's going to give you everything you need for rendering your sequences out of Unreal Engine at the highest possible quality. And what's great about LightForge is that it's automatically going to load those render presets in whenever you enable LightForge in your project. So you're not going to have to do any sort of work to get those presets in there. It's just going to automatically load them so that you are ready to go as soon as you have the plugin enabled. as an Unreal Engine user myself and somebody who really didn't learn Unreal Engine all that long ago, I know what a nightmare it can be to try to figure out some of these problems and how to fix them. You know, that was why we created this plugin in the first place. I mean, ultimately, you know, my idea for the plugin was just a simple way to try to speed up my own workflow, to not have to constantly hunt through the engine, enabling things in different projects and getting things set up, and to spend more time focusing on the creativity and the building aspect of working in Unreal Engine instead of the technical side. So that's really what this plugin is all about. If you're a beginner, this is going to be great for you to be able to quickly and easily optimize your scene and get really good quality renders out of Unreal Engine without, you know, having to learn all of the technical stuff that's behind it. And if you're a professional, this is going to really speed up your workflow because you're able to enable path tracing. You're able to get your scene settings dialed in very close to what they need to be, and, you know, just tweak from there. And then you can always modify everything from the central console right here. And then when you're ready to render, you just click on render, and then you choose one of these presets and you're ready to go. So I really think that this plugin has a lot of potential, and I think it's really going to save you a lot of time. I hope this demonstration was helpful for you to understand what the plugin does, what it's all about, and how it can be used, and how I like to personally use it myself in my own projects. If you guys have any questions, let me know. Send me an email at sam@boundless-resource.com, or you can reach out through the Contact Us page on the website. I'd be happy to answer any questions you have. So good luck creating, guys. I can't wait to see what you guys use LightForge for, and have a good one.